ESA's first deep space mission provided this close-up of Halley's comet in 1986. It was confirmed as a primitive remnant of our solar system, billions of years old, by the Giotto spacecraft launched from Kourou a year earlier. But in Switzerland at the University of Bern, comets can be found much closer to home.
So now we're going to go down into the labs downstairs and we're going to make ourselves a comet.
There are millions of comets beyond Pluto, and though not all the same, they share similar ingredients: water ice, frozen gases and dust. So to cook a comet, it's a simple recipe.
First of all, we need to create a sort of a liquid, and so we're mixing our 50% of our comet, that is this water ice, we're mixing it now with a little bit of liquid nitrogen, and we're using here carbon black. It's finely divided carbon particles. And now we do some comet cooking. Well, the liquid nitrogen is currently sitting at around minus 200 degrees centigrade, and that's keeping the water ice from evaporating and keeping it from sticking together. What we now do is that we tip the mixture into a sort of a mold, and that is a fake comet, ready for experimental studies.
At the University of Bern, the fake comet is about to go under scrutiny.
So we're taking this particular sample and we're going to test it, put it and simulate as if it were in space.
Scientists can use their readings to help interpret data from ESA's latest comet chaser, the Rosetta mission. It's been travelling towards comet 67P Churyumov-Gerasimenko for almost 10 years and is now 800 million kilometres away in deep space, quietly sleeping in temporary hibernation since 2011, and under close observation by the European Space Operations Centre in Germany.
Comets are interesting for a lot of reasons, and one reason where we're really looking, and it's the most fascinating area, is have comets played a role to bring life on Earth?
In 2006, NASA's Stardust mission flew through a comet's tail and brought a sample of dust back to Earth.
The dust was analyzed in laboratories here, and they found, of course, interesting minerals there, but the most interesting thing I think they found was glycine. Glycine is an amino acid which is used in the DNA of life on Earth. It's one of the 4 basic amino acids used in our DNA.
Ground-based observations of comets are extremely useful, but the biggest leap forward in cometary science has been from space missions. By flying alongside and orbiting a comet, Rosetta will gain unprecedented access to its secrets. And in November, the spacecraft's Philae lander will become the first ever probe to land on a comet.
We have an idea how a comet works, but the details are missing, and that we can study with Rosetta. This is one thing. Now, the other hope, and this is also what I believe is the most important point, is if we can really study in situ the composition of a comet. With the instruments we are putting there, they are really very sophisticated. We will get really in detail the molecular composition. We know which elements are there. We will measure the isotopic ratios, and that gives us a lot of information about the evolution history of that comet.
Rosetta could provide crucial information about the origins of life on Earth, but also the question of whether water was brought here by comets.
Je pense que c'est ça la
That's
grande
the big
révolution,
revolution. We can get close to comets and now land on one. And if everything goes well, it'll be an enchanting spectacle for several months. It'll reveal at close quarters what a comet is really like.
Rosetta will shine a bright light on cometary science as our history of chasing comets enters a new and exciting phase.